好，欢迎您参加今天的CA 网络研讨会啊。今天的题目呢是 CANopen 电梯的协议CA 417。那么今天的演讲者呢是CA 的工程师 Oscar Koplum 先生。So, Mr. Koplum, please introduce yourself shortly.
Hello everybody. We continue our series of webinars. Also this time in Chinese language. We have a second CANopen Lift webinar, and me and my colleague Yao will keep you up with the information about CANopen Lift today. So a few words about myself. I am electrical engineer at Canon Automation. I do assisting working groups with writing the specifications, CANopen interface, especially also in working group CANopen Lift that designs various specifications for CANopen interface in various Lift applications, including our conditional monitoring and several other things. Besides that, I do also testing of CANopen, now also CANopen FT devices, Canon Automation.
那我们呢也是在 CA 呢担任这个技术秘书的工作。那么我来负责今天讲前面的一部分 CA 的介绍。Next, please. 那么今天的主要内容呢，就包含这个 CANopen Lift 的应用配置文件和 Lift 协议的一个附加组件的介绍。Next, please. 对于不了解 CIA 的观众来讲，首先简要介绍一下 CIA。那我们是坐落于德国纽伦堡，那这边有我们一个总部，也是唯一的一个办公室。Next, please. CIA 的一个会员发展情况，那么呢，现在在今年呢，我们有大约这个700多家的会员，在我们开始92年的时候呢，仅仅有16家，所以说呢，这个增长的趋势呢是一直保持不变的。Next, please. 那么您现在看到的就是技术小组的一个构成。那么技术小组呢是由这个技术委员会呢来组织和管理的。那么今天的题目呢 CANopen Lift 呢，它就是您看到在这个 IG Profiles 的下面的这个Special Interest Group Lift Control， 那么就是由这个小组呢来讨论的。那么在这个小组中呢，我们会这个开发和维护这个不同的协议。那么如果呢您有这个需求，或者是有一些对于技术文件的一些评论的，那欢迎您参加到我们的这个小组的工作中来。Next, please. 那么关于这个市场小组呢，我们呢提供包含这个在展会上的展台，还有会议的演讲，然后包含一些出版物。如果您感兴趣的话呢，可以联系我们。Next, please. 那么呢，特别对于这个电梯的小组 Lift， 它有一个专门的市场小组，包含的具体的一些工作内容呢，就比如说在这个 CIA 的我们的参加一些电梯专门的展会上呢，可以展示这个会员公司的电梯设备，然后并且呢，您还可以和组内的其他的这个电梯小组之内的其他的公司和成员进行交流。我们呢也会定期有关于这个 Lift 的一些宣传册。Next, please. 那么 CIA 呢，就是我们提供呢，就是说以我们的这个技术规范呢为中心呢，提供给这个系统设计人员和设备生产商，关于技术和市场方面的支持。那并且呢，也会提供研讨会和在技术杂志上发表技术文章的一些提供一些这样的机会。Next, please. 如果您对我们的活动感兴趣的话呢，欢迎您订阅我们的 Infomail。如果您是会员的话呢，可以订阅我们的 Member News， 并且呢，您还可以在一些社交媒体上呢关注我们。Next, please. 那么参加这个成为 CA 的会员有什么优势呢？对于Lift 小组的对于 Lift 的这个规范来讲呢的话，您不仅基本上作为会员呢可以得到最新的和正在这个开发中的规范，并且呢您还可以参加 CA 的可互操作性测试，就是 Plugfest。这个呢这个 Lift 小组呢会每年呢基本上都会有一次。这个设备的可兼容性测试，并且呢，你还可以免费得到这个 CANopen Lift ID 厂商 ID。那么呢，这个也是开发这个 Lift 设备呢所必须的一个。OK，next please。那么下面呢，就由 Mr. Kaplan 呢来开始讲应用配置文件的具体内容。OK，Mr. Kaplan。
Okay, thank you, Yao, for introduction into CAN automation, what we do, what can we help you out. And then we talk about CANopen Lift application, what to start and where to start when you would like to design a Lift application with CANopen interface. So, Lift applications of this kind were done up until last 10 years with various interfaces. CANopen Lift as interface, unique interface using CANbus have been used already more than 15 years, where ever-growing number of companies implementing CANopen Lift, and the community still grows. So that is why we started a series of webinars, especially for CANopen Lift, to ask around if there is an interest to having designing this application whatsoever for. So where do you start if you want to make to create Lift? So basically you have multiple components that you have to bring together that operate in the same network, maybe in several networks, and you can have a unified interface, especially for data transmission of various process data between these components, and there is a host controller which operates the whole network. Maybe it could be done also in various forms. You may also have multiple applications, up to 8 at once, but we'll talk about this later. In generally, before you start with all these things, you know to find where are the requirements for such an application, where to start to design, where do I find the specification. So CAN Automation has maintained a specification, a working group, so-called SIG, Special Interest Group, Lift Control, and maintain specification number 417. It contains 4 parts, which defines various aspects of a Lift design, components, information, and a parameter themselves. Part 1 defines the general definitions, how to do so with CANopen interface, what is CANopen interface for the Lift, what does it mean, and also physical layer specification, how the transmission should look like, what is the bit rate, what is the bit timing, what are the other restrictions we used for physical layer. In addition, as we talk about application, we have multiple components. There is a necessity to define which components and what do they do. So they called actually virtual device, and this part 2 is designed for specifying such virtual device. This part includes also process data we need to transfer from each single of these components to one another. So basically, when you design an application, you have to combine them all together and see which one has to transfer which data. So while the information about the pure assignment of the process protocols, data protocols, so-called PDOs, in part 2, The part 3 defines exactly in details this video from communication point of view. How do they have to be sent, which intervals, and the second is which data do they send. So finally, the fourth part defines the application list of application parameters, also in details, how can they be mapped into process data, how they can be accessed in general, all those things you will find in part 4. Basically, this is the most part of the object dictionary you have to implement. You have to look in part 4, but refer to the other various parts to know where to locate, where these data are actually located, in which components called virtual device. So beside that, we have some recommendation technical reports which assist you in implementation of various add-ons for lifts, such as bootloader for loading the device functionality, the program which means what the device actually do, its functionality. Beside that, the second part we defined, specified recently, is lift power supply unit. This is also so-called reserve power, has a role of reserved power, and also available as used in as a renewable power supply based on renewable energy sources. That is basically the specification you need to know about when you start with this development, or you want to look into this development. How does it look like? So the specifications are obtainable from CANopen. On our site, you can find basically the publicly available parts, publicly available version of the specification. If you become CANopen member, you have the access to the proposal, very early proposal for the draft specification, which can be used and implement this profile, which is constantly adding new functionality, improving the order. This is what you gain if you become the member of our organization. You have the access to the very recent version of specification. Beside that, is more than this, you can also bring your requirements to this specification. If you say, well, we need certain things having supported for all Info 17 for all manufacturers of the devices, so we can introduce them as the part of the specification itself. This is what you gain as a member. So, what is actually CANopen in this case? What is the specification? What does it consists of about? Basically, we are talking about application profile. This is a way of doing things, of defining specification from the point of view of the system design. So all parameters, object dictionary, process data exchange, everything is completely pre-configured for the lift application. So every component defined in these specifications is predefined for the very communication between the other components, which are logically integrated into the whole application itself. Beside that, the application profile allows the standardized data interface. We're starting with definition of the device profile for each single component. There are many components of the lift application. There is not only a lift controller, but there could be drive controller, drive unit, the car moving around, the doors of the elevator, which are controlled as well, the buttons you push to call the elevator, and so on. They are defined in a specification, and the main parts, important parts, they are mandatory information, which gives you support immediately information on a device type. then how the error shall be handled, the process data communication. For those of you who have not experienced CANopen, this webinar is actually has a prerequisites to know a bit about CANopen, otherwise it will be difficult to understand this. Process data object is the protocol of CANopen, allowing you to transmit the data straight from one device to another without any specific configuration information in this message. This is just pure data as it meant one day once for CAN transmission in general. Sorry. There is, of course, application-specific data types for Lift application only. This makes this application profile standardization level much higher than the single profile for every component would be. There are also standardized application objects. It means that all components, Lift components you design, are the door controller or drive controller, or the door itself, or I/O modules, or the host controller, they have exactly exactly one set of parameters for each single one, predefined exactly which parameters are there. So among all host controllers, or among every available drive units on the market or door controllers on the market, you will find these parameters, these standardized application objects. There is, of course, an opportunity for our members or everyone who designs this profile to design their own functionality additionally to the Lift, which is not a main part of standardized functionality. So you can have your manufacturer-specific functionality. This has to be put in a very specific range of indexes. So this is a slide showing you in generally possible application of the profile to the very specific requirement. For example, you can have up to 8 elevator shafts in your building, or whenever you have them, they could have up to 254 floors. So this is basically the maximum possible design architecture you can have. Practically, you have only few shafts, also maybe only one, and you have up to few floors, which much easier makes your task much easier. But in general, specification 417 supports up to this maximum architecture of the Lift application. When you go a little bit into details on that, then you see basically what are virtual devices. Ask yourself, what are virtual devices? So there is necessity to design a communication between Lift components, but Lift components are physical devices. CANopen is software, but there could be also a case when we have in one and the same hardware box, we have several functionalities, and that is where the virtual entities come into place. There are several pieces, ranges of indexes in an object dictionary, which define the parameters for these specific virtual devices. So you can locate them into one and same device, support all those devices, and you have up to several devices inside of each component. But usually, for simplicity, we talk about each single physical device will also incorporate and contain only one virtual device. These virtual devices are generally listed in there. You can find them by name and by the assignment of the data they exchange between each other in a part 2 of specification 4.17. So you see card drive unit, sensor unit, panels, cutoff unit, light barrier, and so on. Also, back to what I said at the beginning, I said that some of this virtual functionality also can be located in one box. This is illustrated basically in this structure diagram of the network, Lift network, with a blue color with blue area. For example, at the top of the picture, the slide, you can see that call controller, door controller, panel controller, and drive controller located in a very same device. But they are controlled completely independent in them. You have the parameter in object dictionary with them, and you have an abstract level, maybe only host controller, which supports all this functionality. The single ones are, for example, sensor unit, could be. So this network shown in there, in a part 1 of the specification, you can find actually various examples how the network could look like based on these virtual devices, how you can combine them all together, how many networks can you have for the case that you have not only one lift shaft, but multiple lift shafts, or you want to have several networks, separate several components from each other. For example, host controller controls the whole network, but there are 2 CANopen networks. On one, the drive controller hangs, on the other, hanging other things like sensors, for example. This is all possible. You can find this information in part 1. So with the next slide, as you can see, the communication, how does it work in CAN, producer and consumer, is this usual way of data is transmitted. In a broadcast is one producer transmitted data to every other consumer. In the picture, every single element is a virtual device. Is illustrated, it is hanging on a network. It communicates also in both ways. And it can contain also data it produces and data it consumes. This is basically the idea of this CANopen application. So every single device has reception and transmission configuration for it, which data it receives, which data it transmits. So if every single device does have this one, they do not need any supervising controller which completely controls what they do and how they do this, but they can do this by themselves. That's the idea behind the distributed system, which CANopen Lift also is. And the task of the host controller in this case are to maintain and observe the information on the bus, seeing if the network is completely operating, and it doesn't need actually to collect all the data from all devices and sort it out, because the devices do that themselves if they are properly configured for that. So, as I said, the list of the devices you will find in the specification part 2. There are only a few devices listed for the moment. There are many more already defined. Sorry, not many more, but a couple more are defined in there. They have assigned specific number to distinguish between them, which we look into this in the next slides. For example, there is assignment. You can have multiple virtual devices in one. This means for the case I've mentioned before, this blue area, call controller, car door controller, and some other key components can be in one. this means I will set multiple virtual devices into one. So you see, this is the flexibility. If you design your Lift application, then you have the opportunity not to design only one piece of component, if you do it completely, but you can combine them as well. So the object 1000 gives you the information about the device. And if you design the system, this object collected by the host controller from every single other components gives immediately the information which virtual device, which functionality has. So it helps for the network configuration, because during network configuration, you ask around what devices have what functionality and how do I configure them. You require, of course, the addressed files for every single devices or device configuration file, depending on how you do so. For all components, you have it. And typically, the control unit, Lift host controller, does this task, collecting this information, the object 1000 from each single component. It stores in an object 6000 and knows exactly how many components are connected and knows whose they support entirely profile and what functionality do they support. You see, the second upper bit, virtual device code, is the previous slide I mentioned. You will find in the part 2 the numbers are assigned to each single component in there. So by this means, it is known which devices are currently getting the network. Since we talk about the application profile, you have up to 254 floors. You can implement in your application that so many floors can be maintained. You have also up to 8 Lift applications, not only one, but 8 application doesn't actually mean that this is 8 shafts. It could be 2 Lift cars in one shaft. Also 2 applications. Now, independent from this, each application can control though only one Lift car. So to make it more useful, of course, we had and we did actually structured the application layout of application parameters for each single application, Lift application, see up to 8 Lift application. And within this application, which you see in blue color table with index and description, it is structured within, also assigned by the virtual device areas. So, for example, the first one is panel input unit. So inputs for elevator, for the Lift application 1, all the parameters for input are assigned in this range, 6100 hexadecimal up to 6100 FF hexadecimal. This is about or exactly 254 parameters available. The same way is designed for each single virtual device, which are more likely to be a physical device as well. So we structured this very precisely between them. And if you need to do so, if you design a devices, you know where to put your parameters. And when you are a system designer, you know where to locate the information about these parameters. So this is done. And in such a structure you see in a blue color is done for every of the 8 applications. So it's completely pre-configured what refers to the parameters themselves. But it's not only one thing. Second one I've talked about, when you design this, you look into specification and you have a task, you have your project, Lift application, and you see, okay, I have seen in part 1 there are various schemes how to design the network itself. How can I manage my devices? Where should I locate them? Do I need one network? Maybe I would like to separate networks to operate them more effectively. Maybe there are some critical applications, safety-related applications, so I have to separate pieces of the components. And that is where you say, okay, we have, for example, two networks. And one network is using control, the whole things, and itself the drive controller, for example, hangs in the same network. On the other hand, the same other network may have some sensorics in there, which are located in a more secure environment to prevent some disturbances or even damaging due to moving parts. So BASIC is not only virtually separated, but also physically separated in the network. For these reasons, also special components designed, special entities within it that allows to do so using some kind of bridges. So you separate two networks, but you contain, similar to the gateways, the application-specific information, application-specific data. You could connect them with each other, and within this bridge, the data is going exchange. Usually the bridge is located in the lift control application, in the host controller, so it can, additionally to its own task, if it has capabilities, also to manage all networks within the lift in regard of their application data. Now back to this producer-consumer things, you have various device functionality, you need to communicate the data across the network, maybe several networks, kind of gateway devices required in there. But if you want to have the simplicity of the network, you might consider the things like the previous one, designing some kind of bridges where one specific device like host controller, lift controller can manage the both networks and exchange data between them and collect information, reassign all the information necessary between the networks. When you come to the network configuration as a complete application in there, the specification specifies for each single component already data it has to contain in there. You configure accordingly each single component, and you have completely pre-configured network, which completely operating itself, except it, depending on the devices, it cannot start itself, and these tasks are assigned to the lift host controller. Also, it does some specific stuff like configuration of the network as well. So even very simple components which have not much intelligence in there, they are just can exchange the process data on the bus, but they cannot manage themselves and the other devices. So such very simple devices can still operate in such a network. That was actually the idea. So that you design a kind of master-slave, or the modern language manager and server, design such kind of application where the manager does all the tasks necessary to keep and maintain operation of the network itself. The data configuration is provided in a part 3 as process data. In each single device, however, this process data configured as the data it is transmitted as TPDO, or the data it is received by the device. There is certain peculiarities regarding process data. Object protocol used the so-called MPDO, but you have to look into specification. You're welcome to ask ask question. So the devices become configured. You will find configuration for PDOs independently on the device in part 3, but dependent on each single virtual functionality. This is the part 2, which says which process data have to be assigned to which single component. So based on that, we have completely pre-configured network, not only with parameters themselves for each single device as mentioned previously, but also with exchanging sorry, of the application data. This called again the process data object. And again, you have a similar table where we say for each single application, Lift application, we have also assigned process data for each specific virtual device. So there will be no collision between this process data because they are assigned a very specific numbering and a very specific content only for this special virtual device. So to make this also same way simple and very structured to allow efficient programming of the when you implement when you design a device, it is also structured in a very certain way. So there is certain PDOs assigned as MPDO, which allows to transmit up to 254 pieces of data. Maximum fitting into each PDO, which would be is actually 64 bits or 8 bytes. In contrary to the usual PDO transmitting up to maximum 8 bytes, that is a certain advantage, but this has its downsides, and this is necessary for Lift application because it is the case that there could be some additional information the manufacturer would like to have, but he run out of usual PDOs for that because they're completely predefined for completely all 8 applications and completely assigned, only a few left. Thus, MPDO helps you out to sort your process data in the network. So as you can see, a certain range of process data assigned for MPDOs, there are certain range assigned for virtual inputs, there are certain range of PDO assigned to Lift application 1, Lift application 2, and so on. And within this range, they are also structured which virtual device uses them, either for reception or transmits this data. We also, since it has to be done like this, there's the idea behind this, we do complete assignment what is in the network, which virtual device receives which PDOs from which other virtual device, so to say. And by this one, you have a complete list in tabular form like this one, where you know entire mapping assignment of the whole network, and you know what data goes in where, what is going on the network in general in there. So for configuration of PDOs, you have to have COPID. In this case, we talk about application that's completely configured. And since if we use also, as usual, node ID for default configuration, as in specification 301, or device profiles, it doesn't longer apply in here because you run out of node IDs. We have only 127 in it, and you might have also physically so much or half of this, which is sufficient for every Lift application. But how about to make the cross communication, what assignment should they have as well? They will run out of the options if we use node ID within this. So we said every physical device assigned in the network has node ID, but the PDO CAN ID is no longer dependent on it. And you can use the whole 512 CAN IDs allowed and supporting within one specific network, assigning in a certain way as the numbers to each single PDO, no matter if it is transmitted or received by any devices. So this is the reason basically for PDO linking. So you have only one, you have basically only PDOs on the network. The configuration into transmission and reception is only done in the device itself, but on the bus it appears as a PDO. For that reason, we need only to have only one CAN ID for each PDO. And in each device, it is assigned to transmission or reception of this data. So by this means, just a short example, we have car position, car door unit, car drive unit, and so on, having such things in there. How do I know where to go? This table gives you this information. So for example, the PDO with CAN ID 18C has the car position unit, has car drive unit, and car drive controller. But the point is to know which device needs this data and how it does it handle. So as we see, car position unit transmits this data on the bus, but the recipients, receptionists, or consumer of this data are drive unit and drive controller. So this means basically that is the host controller saying lift has to be moved to a certain position. But this data should be also transmitted to this car drive, which actually drives the car in there. But the car drive has to receive this information, doesn't transmit this information back. It needs to receive this. What it can transmit back is that the position is reached, for example. There will be another PDO. So by this means, this whole network operates like this. We have a complete assignment of this process data, and operation goes from itself without any special intervention for distribution of these messages. Is completely self-sustaining in this case. In the second table below, you see exact information which is coming with this message, as for example, message 1, position unit submits the data and the remaining 4 bytes are reserved. So they are completely transmitted, but they are empty or contain the value that are not evaluated by, for example, car drive unit or car drive controller. It actually reads only the byte 1 and byte 4, since it knows, every device knows, it is configured for that, that it is the value of the position, and it resides then in an object 6383 in car drive unit and car drive controller. So this was an example to take this one, but that is basic concept how the lift application operates from the communication point of view, from the configuration point of view, and where to look at and how to begin the design. For further questions, please refer to us. We could help you as far as it goes. Testing of the whole application in a single component is a little bit difficult because we do not test completely configured devices, but merely basic devices having assigned only default values in there. There will be, according to specification, basic and open specification, basic protocols 301. We can test, of course, conformance, CANopen conformance of such devices, but it is not the point in there. More that you would like to have if these devices are actually operating in the network. That is called Plugfest, interoperability test, which we do on a regular basis. We did this also this year, despite the pandemic, and planning to do so in there. The various manufacturer of components come together, bringing their devices and test the signal network in a one-to-one session or in a single network, seeing how the CANopen components for Lift performing in this network. If you become the member, you can also participate in such a Plugfest. So in the next slide, in the next part, I would like to say about CANopen add-ons. There will be a bootloader, there will be gateway applications, there will be also this power supply unit we have in there, such things which gives you additional feedback on what is going on with CANopen Lift, how does it progressing, and what are new functionality is supported now. So condition monitoring means actually in this case that check out if single components of the lift are required maintenance or not over the time. The design is based on VDMA organization proposal for the structuring of every systems based on their functions, their application, and their automation level. So for that reason, we design it as well. And basically it comes down to the functionality supported in there, what values are required, what values are collected, shall be collected in the network, and which values have to be transmitted further to the processing station, whatever it might be. It could be IoT-based, cloud-based service, whatsoever, providing, however, not all the data, because it will be push the limits, push the network to the limits due to communication speed and payload, but submitting unified set of data that is reusable by any lift component, submitted in a very specific predefined way. So this is the structure of, rather say, architecture. What is this levels? Are these levels? How operate with them? What do they do? As you can see, we feed in the parameters for the processing, for example, current value, current state of the component, current level of the component. It could be also voltage. It could be number of trips. Let's say in bigger things about the lift application, so you know the component work out completely, its resources has to be replaced or maintained. That is also input, and a whole system state goes into this as well. It is also necessary to know what component does it have, and also gives out information how shall it be maintained if necessary. So it means should it be condition monitoring or timely monitoring or other things used in there. There are also limits as upper and lower thresholds for the physical values which are serving as the parameters for monitoring, which are monitored there. Also their reference values, so you know if the value you received actually distinguishes with them or goes lower or above the threshold. Finally, there is also generated the status. The general status is generated. Either the component needs some maintenance or replacement in this case. For that reason, there could be the case that each single component can monitor its data by itself and transmit this data on the bus. That could be done, yes. So I have in this slide shown the typical network which is maintained by the host controller. This is even the case that there are two networks hanging around, a left network and a right network connected in there. On left network, we have several components, same on the right. There are mostly panels in there. And green marked device on the right side is the condition monitoring unit, which we have specified additionally that it could be the case that there are many data which one single device cannot collect. So one single device submits data simply over the bus to the host controller. If host controller doesn't have the capabilities for this, how can you do so? You should be integrating additional device. So we provide this as an option. You can do this by host controller, collect all the data from the devices, or merely the devices send their condition monitoring data into the network and host controller collects it. Or there could be a condition monitoring unit which collects this data going on the bus from each single component still. Or it may also request the data from each single device. And this device may have also capabilities to be connected over TCP IP through the cloud infrastructure all the way to the end customer who's evaluating this data. On the other hand, we have TCP IP gateway purely in case this is just a variation of this. We have no condition monitoring unit, or yes, we still have it, but we want to collect additional data. Then using this gateway, you can transform all this data collected in there to your specific cloud service and finally to the place where the data is going to be evaluated. It's just a small example. How does it work? And then next one is more or less how to have a structure of the devices, the network of each single physical component, what parts does it have, and so on. And if the device should have a bootloader, so it has nothing in the first place, has a very small program in there called bootloader, which allows the device to become specific functionality. So we define this bootloader. How should it be handled in this case? If you're interested, you're welcome to look into this implementation guideline, how to do so. This bootloader specification, let's say our implementation guideline is based on our basic bootloader parameters and recommendations how to do so in specification 302-3. The second one from the application level is this implementation guideline for this power supply thing. We have not defined it by now, but in recent time, about a year or so, the requirements came from several of our members to do so. provide some protective circuit in there, allowing to have a reserve power for the certain lift applications. So we design it. You're welcome to look into this in specification 4.14. The reason is using renewable energies, a reserve power for the lift application for certain cases. So it's entirely connected to the network. And if industrial supply is no longer available for various reasons, this power supply comes into the play. However, it is not designed for long-term operation. So to summarize these things, application is used already by many companies. Their number is growing. More than 40 companies already support CANopen interface in their CANopen Lift interface. This is unified network. The devices are practically very interoperable due to multiple interoperability testing, those Plugfests we had in past time. So basically we continue this one to make these devices in many networks always interoperable, allowing them to connect to every network if you replace the devices, and as immediately available in there. Specification 4.17 is still in maintained. This means there's still interest in there. There is not only fixing some minor bug issues, but mostly introducing new functionality, such as emergency telephone, position supervising unit. There's power supply, special power supply, and we having some further communication things, allowing certain indication of the data transmitted over the things to condition monitoring reasons or just to evaluation of the network itself. So this is all from my side, basically for today. I just wanted to point you out to our visitation of certain exhibitions. You can come, if you come to these exhibitions, you meet us on site and could ask us questions, either technical or marketing related things. We are also in a lift-related conference and exhibition in Interlift in 2022. Next year in Augsburg. And beyond that, also you can find us, I hope it works out, in Bauma in China, the same year, at the end of the same year. For our next webinar series, we are planning for the next year as well. Currently, we're still having some remaining for this year. In Chinese language, we point you out to we're having webinar in CanExcel by the end of the year. My colleague will provide it, and Ms. Yao. And it is quite an interesting new development in there. You're welcome to join us. Within 1 hour, you learn about what is CanExcel and how you can work with this if you're planning to. So you can reach us as usually by emails, can contact us, can look into the website, see what we have, as my colleague said. Would like to thank you very much for participation today and wish you pleasant time. Please take care and see you next time in our webinar series. Bye-bye.